So in the last video, we used the change the variable theorem to integrate compound functions or composite functions. And in this next theorem, we'll add what happens if we want to figure out a definite integral. So if we're trying to integrate from a to b the function f of g of x times g prime of x. So this is, we've recognized that we are in the appropriate form for doing u substitution, right? This would be my u, right? And this is my du right here. So if we're in that form, then we can just rewrite this as f of u du, because that's exactly what this expression is. But we have to change our bounds of integration. We're now going to go not between a and b, but g of a to g of b. Or really more naturally, I'll think of this as u of b and this as u of a. Right, so that's going to be our approach. So let's compute, say, what is the integral from negative pi over 4 to pi over 4 of cosine of 2 theta d theta. Now we cannot use the regular cosine rule because I've got another function inside of cosine, namely 2 theta. But I can call that u. So I'll let u be 2 theta. Then du is equal to 2 d theta, or in other words, d theta is 1/2 du. So that takes care of my u substitutions, but I need to take care of my bounds as well. So I need to know what my new upper and lower bounds. So the lower bound will be given by u of, well, I evaluate it at this lower bound. So negative pi over 4. But what is u? U is just 2 times its input. So this is equal to 2 times negative pi over 4, which is negative pi over 2. Similarly, my upper bound will be given by u of pi over 4, which is equal to pi over 2. So putting that all together, that this integral is equal to the definite integral of negative pi over 2 to pi over 2. These are my new bounds of integration, and it's cosine of u du. And now if I take the antiderivative of cosine, I get, I forgot my 1/2. Let me fix that, right? This is supposed to be 1/2, so I need to put that here. So times 1/2 du. So the 1/2, that's a constant, comes out. Antiderivative of cosine is sine. So this is equal to 1/2 sine of u evaluated between negative pi over 2 to pi over 2. Now let me point out a mistake that is very common amongst new calculus students is they'll say, oh, well, u is equal to 2 theta, and put it back in for here. That is a no-no. Don't do that. Yes, we did that when we were trying to find indefinite integrals, when we were just trying to find the antiderivative of a composite function. But the whole reason we changed our bounds of integration was that we're going to put everything in terms of u now, and so we don't have to go back. This is u is equal to pi over 2, and u is equal to negative pi over 2. So we just do what the fundamental theorem says. This is 1/2 times sine of pi over 2 minus sine of negative pi over 2, which is equal to 1/2 times 1 minus 1, which is just equal to 1. So the definite integral of cosine 2 theta bound between negative pi over 4 and pi over 4 is 1. That is the value of that integral. All right, let's do another example. Let's say the definite integral of x squared divided by 4 minus x cubed quantity squared, and we'll evaluate it between -1 and 1. So again, we need to figure out what is the u. My first guess would be, let's let u be 4 minus x cubed. So if u is equal to 4 minus x cubed, then du is equal to -3x squared dx, which tells me that dx is equal to -1 over 3x squared du. So that'll take care, hopefully, of our integrating factors in here. But we need to take care of our bounds as well. So u of our lower bound, -1, is equal to 4 minus 1 cubed, which is 5. And our upper bound will be u of 1, which is 4 minus 1 cubed, which is 3. So putting that all together, this definite integral is going to be the integral from, so instead of -1, we evaluate u at -1 and we get a 5. So the lower bound will be 5. The upper bound, we put a 1 into our u function and we got 3. So our upper bound is going to be 3. X squared divided by u squared. And then what is dx? Dx is -1 over 3x squared du. That x squared and that x squared cancel. And so this is equal to -1/3 the integral from 5 to 3 u to the -2 du. And now this is a nice form. We know the antiderivative is just a power rule. And so this would be equal to -1/3 times -u to the -1, evaluated between 5 and 3, which is equal to -1/3 times -1/3 minus -1/5, which simplifies to be 2 over 45. Okay, so that's our answer. The integral between -1 and 1 of x squared divided by 4 minus x cubed squared is 2 at 45ths. So that kind of wraps up some examples using change of variables, or u substitution is what it's usually referred to. And the only way you get proficient at this method is to do lots and lots of practicing. I could sit here and do tons of them, but it's not till you get your hands dirty and look at problems and trying to figure out what's the u, and the more experience you have, the quicker you'll get at determining, oh, this is going to be a good candidate for you, and here's how I solve the problem. So Happy mathing, and see you next time.